Some of the most useful energy technologies are not secret, rare, or experimental. They are simply overlooked. When people talk about energy innovation, the conversation usually focuses on large power plants, massive solar farms, or new battery technologies. These developments are important, but they are not the only areas where energy innovation is happening. In reality, many smaller and practical energy systems already exist. They are used in workshops, homes, research labs, and small engineering projects around the world. The problem is that most people never notice them. These technologies are not hidden because someone is trying to keep them secret. They are ignored because they operate quietly in the background of modern engineering. Understanding them can change how we think about energy. The first reason these technologies are often ignored is scale. Large power plants attract attention because they produce enormous amounts of electricity. A hydroelectric dam or a nuclear plant can power entire cities. Small-scale systems do not have that kind of visibility, but small systems play an important role in the way energy is used and managed. For example, small generators are one of the most common energy tools in the world. Portable generators are used in construction, emergency situations, remote locations, and backup power systems. They allow electricity to be produced wherever mechanical energy is available. The technology behind them is not complicated. A rotating magnetic field inside a generator converts motion into electrical energy, yet many people never think about how flexible this system can be. Generators can be powered by gasoline engines, wind turbines, water flow, or even manually operated mechanisms. This ability to convert different forms of motion into electricity is one of the most versatile features of modern energy systems. Another overlooked technology is resonant energy transfer. This concept was explored more than a century ago, and is now used in modern wireless charging systems. When two electrical coils are tuned to the same resonant frequency, energy can move between them through an electromagnetic field. This principle allows devices to charge without direct electrical contact. Wireless charging pads for phones and other devices are practical examples of resonant energy transfer. The technology is not mysterious. It simply requires carefully designed coils and circuits that oscillate at the same frequency. Although this method is usually used for small devices today, the concept itself has been studied for larger applications as well. Another energy technology that receives little attention is energy recovery. Many machines produce energy as a byproduct that is never used. Heat from engines, motion from braking systems, and vibration from mechanical structures all contain usable energy. Engineers often design systems that capture a portion of this energy and reuse it. For example, regenerative braking systems in vehicles convert kinetic energy into electrical energy during deceleration. Instead of losing that energy as heat, the system sends it back into a battery. Similar concepts exist in industrial machines where excess heat can be redirected to support other processes. These systems do not create energy out of nothing. They simply reduce waste, but improving efficiency is often just as valuable as generating new energy. Another example involves local energy generation. Large centralized power plants dominate the global energy landscape, but small local systems are becoming more common. Solar panels on homes, small wind turbines, and compact battery storage systems allow electricity to be generated closer to where it is used. This approach reduces transmission losses and provides more flexibility in managing power. Local energy systems also allow individuals and communities to maintain electricity in situations where the main grid is unavailable. While these systems are becoming more visible, they are still often treated as secondary solutions rather than primary infrastructure. The reason many of these technologies are ignored is simple: they are not dramatic. Large power plants and massive engineering projects create impressive images and headlines. Small systems that quietly improve efficiency or provide localized power do not attract the same attention, but energy innovation often happens through incremental improvements rather than dramatic breakthroughs. Engineers frequently focus on solving practical problems such as reducing losses, improving reliability, or making systems easier to maintain. Over time, these improvements accumulate. The result is a network of technologies that work together to create more resilient and efficient energy systems. One important insight is that energy systems are rarely defined by a single technology. Instead, they are built from combinations of tools and techniques. A modern electrical network might include large generators, renewable energy sources, battery storage systems, power electronics, and intelligent control systems. Each component plays a specific role. Ignoring the smaller technologies in this system makes it harder to understand how the entire network operates. Another important factor is accessibility. Many of these technologies can be studied and understood without large research facilities. Small generators, resonant coils, power converters, and energy monitoring systems are widely available. Students, hobbyists, and engineers often explore these systems in workshops and small laboratories. By experimenting with these technologies, people gain a better understanding of how energy flows through electrical systems. That knowledge can lead to practical improvements in efficiency, reliability, and system design. Energy innovation does not always come from massive industrial projects. Sometimes it comes from small experiments and careful observation. Technologies that appear simple on the surface often reveal complex and useful behavior when studied closely. Understanding these tools helps build a deeper perspective on how energy systems function. The technologies themselves are not hidden. They are simply overlooked because they operate quietly and do not attract attention, but the people who take time to study them often discover valuable insights. Energy systems are not built from a single breakthrough, they are built from many ideas working together, and some of the most important ideas are the ones that people rarely talk about. If you enjoy exploring practical energy concepts and the technologies behind modern electrical systems, consider subscribing to the channel. New videos break down engineering ideas in clear and simple terms so you can understand how real energy systems work. You can also check the description for a useful resource that outlines some of the basic components people examine when studying small generator setups and other hands-on energy projects.